Hello and welcome to the AI Research Roundup. I am Alex. Today is May 9th, 2025. We are looking at a research paper from Hugging Face's trending list, published 8 days ago, titled Unlearning Sensitive Information in Multimodal LLMs, Benchmark and Attacked Defense Evaluation. This paper addresses how multimodal large language models, these are AI that learn from both images and text, can leak private data. It introduces a new benchmark called Unlearning Outside Knowledge VQA, or UnLOK-VQA, and an attack and defense framework to assess targeted unlearning, basically making these models forget specific information effectively. Okay, so to better visualize this challenge of effective unlearning and the attack and defense framework the authors propose for evaluation, which is essentially a structured method to test how well defenses hold up against attempts to retrieve forgotten information. This first figure is quite illustrative. We see an example where a multimodal large language model is asked for a street name from an image. Initially, it might leak the answer. A defense then makes it say, "I do not know." But critically, an attacker might still extract that original street name, showing the difficulty here. Alright, so building on that attack and defense framework, this figure really breaks down how the Unlearning Outside Knowledge VQA benchmark is constructed. You see, at its core is efficacy evaluation. Basically, did the model forget the specific target information, like a dog's breed from an image? Then, to test generalization, meaning how robust this forgetting is, varied images and rephrased questions are used, often in what are called black box attacks, where the attacker only interacts with the model's inputs and outputs without seeing its internal structure. Finally, specificity evaluation ensures the model does not forget unrelated knowledge. Okay, so this table then details the actual numbers from the Unlearning Outside Knowledge VQA benchmark, showing attack success rates against different unlearning defenses. These defenses are applied using low-rank adaptation, or LoRA, an efficient model fine-tuning technique. We see various attacks, including white box attacks where the attacker knows the model's internals. Attack success is measured by attack success at B. How often an attack works within a budget of tries. Critically, the table also shows model damage using metrics like random delta accuracy. The head projection defense, or HP, really stands out here, proving most effective overall by significantly reducing attack success. Now, digging a bit deeper into what makes these unlearning methods more robust, this figure illustrates the impact of model size. It compares a 7 billion parameter model shown in blue with a larger 13 billion parameter model in red. Both are using a defense called fact erasure, which tries to make the model forget specific facts. We see that against both a multimodal rephrase attack and a white box head projection attack, the larger 13 billion parameter model consistently shows lower attack success. This is a promising finding, suggesting that scaling up models could make them inherently better at keeping forgotten information forgotten. So while larger models show promise for better unlearning robustness, the Unlearning Outside Knowledge VQA benchmark itself is carefully designed to test this. These two charts, Figure 5 for image variations and Figure 6 for question variations, show the average distance of different evaluation data points from the original target information. The tallest bars, labeled random, represent data most distant from the target. Then neighborhood points are closer, and rephrase points with the shortest bars are closest. This structured proximity is key for evaluating how well unlearning generalizes and its specificity. That is, how it impacts related versus unrelated knowledge, which can be tracked by changes in model correctness called delta accuracy, or increment accuracy. Alright, and this next table gives us a really good look at some concrete examples of these evaluation samples from the Unlearning Outside Knowledge VQA benchmark. You can see the target data on the left, like an image of a cat in a suitcase and a question about it. Then, we have rephrase images and rephrase questions of varying difficulty. These are used to see if the model still remembers the information if the input is slightly changed, testing how well the unlearning generalizes. Finally, neighborhood images and questions are related but different, helping to check if the model accidentally forgot things it was supposed to keep, which is that specificity we talked about, often measured by changes in model correctness called delta accuracy. Well, seeing those detailed examples from the Unlearning Outside Knowledge VQA benchmark really highlights the challenge. To wrap up, this work tackles how multimodal large language models, which process both images and text, can be made to forget sensitive data. The new benchmark and attack defense framework are crucial here. Key takeaways are that the head projection defense shows real promise, and that larger models seem inherently more robust to these unlearning attacks. It is still a complex problem, but this provides a great path forward. Thanks for joining me, Alex, on the AI Research Roundup.